Over the last decades, global temperatures have risen, and we know that this has changed a couple of things in our oceans. For example, the increase in heat and greenhouse gases have caused sea level to rise, increased surface temperatures, and ocean acidification. Still, we don't know how ocean currents have responded to our changing climate. Let's move on to how we measure the currents. The surface of the ocean is not flat. In fact, as it moves, the surface goes up and down. This movement of the ocean surface has been captured by satellites since the early 90s. Satellites located at more than 1,000 kilometers above the surface can detect changes of the ocean surface of only a few centimeters. This map of the surface of the ocean shows more than half a meter changes, and it is changing everywhere. By measuring the slope of these small-scale bumps and valleys, we can infer something known as mesoscale currents. So, why are mesoscale currents important? Mesoscale currents move heat and nutrients across the ocean, and they influence the ocean circulation. In other words, mesoscale currents are like the weather systems of the ocean. Our research found a puzzling change in the mesoscale currents. While the regions with the strongest mesoscale currents, the mid-latitudes, have sped up, the tropical oceans controlled by interannual variability, like El Niño, are slowing down. The currents in the ocean are not evenly spread. In fact, there are many narrow and strong currents. For example, the Gulf Stream in the North Atlantic, the East Australian Current along the east coast of Australia, and the world's strongest current, the Antarctic Circumpolar Current. These and a few other currents have sped up more than any other region in the ocean. As the mesoscale currents intensify, we expect the ocean to change, not only in the way it moves, but also how it captures heat and carbon. The global and regional changes we have observed so far are a combination of complex factors. For example, regional increases in winds, changes in temperature structure of the ocean, and more. We know that the mesoscale currents have sped up, but we are less sure of the consequence this might have on our climate.